Okay, I think it's about time. We are going to get going. So, for anybody jumping on, expecting to see material design in XAML, taking a break from that tonight to go play on a library called System.CommandLine. So, just a brief history for those people who are unfamiliar with it. System.CommandLine is an open source project being backed by some Microsoft folks who are interested in seeing a better command line library. So it handles parsing of your command line arguments, it handles invocation, and there's even a rendering portion of it as well. The more interesting portion of it is there's a library that's still kind of to be determined to be named that has been called System.CommandLine Dragonfruit. And that's kind of where our saga starts tonight. So I'm going to flip over to sharing my screen, and I will catch everyone up to where we were at. So this issue came in because System.CommandLine Dragonfruit lets you create strongly typed main methods. So what that means, let's jump over here and I'll show just a quick example from the wiki. Normally in a command line application, you type your standard public static void main string args. Just like this, it's fine. The problem is dealing with this string array can be far from trivial. So what System.CommandLine Dragonfruit does is aims to make the simple use case for command line apps easier. So rather than typing static void main string args, it ends up being static void main, and then you just declare your arguments in here. And Dragonfruit's got all kinds of fancy bells and whistles to try to make this awesome. By default, it handles showing up version with dash dash version. It handles generating help with dash dash help. It even reads the XML docs if you've generated those for your help output. So all of that works, and it makes at least the sort of the 80 or 90% case of what most people do with command line apps really, really easy. So that you don't have to think about how do I go from this into the method that's actually going to do the work. It just jumps straight into the method that's actually going to start doing the work of your command line app. So where that leaves us is Elin Hassan, I apologize, I'm probably butchering that name horrendously, pointed out that Dragonfruit is actually failing on slightly older MS builds. I believe this is MS Build v14. I think that's Visual Studio 2015, if I'm not mistaken. And .NET 4.6.2 specifically calling out that it was the old project file format. So if you edit your CS proj and you see tons of XML, you're probably on the old CS proj. The telltale sign is if you see that root level project tag, if that has like XML namespace stuff in it and it's not just a straight tag by itself, you're on the old CS proj. And so he pointed out that this guy was failing. And so I took a stab at trying to fix this and pointed out one of the key problems is that Dragonfruit generates an async main method. So let's go look at that real quick. So even though you write your normal main, you write a method like this, and it does support async mains, so you can do the return type of int or task of int, depending on what you end up needing. But let's look at how Dragonfruit actually works. So it's actually a fairly simple path through. Actually, what am I doing? I've got Visual Studio open. Let's go here instead. So inside of Dragonfruit, there are some targets and props files. And with NuGet packages, if you happen to create a target or a props file where the file name before the .targets matches your NuGet package ID, these automatically get included with the project when the NuGet gets installed, which is great. It gives you a nice injection point to be able to have your library do stuff. So in this case, Dragonfruit injects this target, so core generate Dragonfruit program file. Currently we're only doing C#. There is an outstanding request if anybody wants to do Visual Basic as well. But then more importantly, it goes through and it just generates this file. It's nothing fancy, public static async task int of main, and then it calls this execute assembly async, which is great. It's an asynchronous method, and this all works. And the problem is right now this is using the new CS_proj format. And so it needs to be updated to support the old CS_proj format for anybody working with maybe it's still stuck in Visual Studio 2015 who wants to take advantage of Dragonfruit. The problem is just updating this isn't quite good enough, because once we update the targets file to support the old CS_proj format, we now have the problem of targeting the old .NET Framework 4.6.2 doesn't allow asynchronous mains. Specifically, and I should say .NET Framework 4.6.2, using the older compiler doesn't support asynchronous main methods, which is a problem. So now this whole method needs to change to support synchronous. Okay, we can do that. So when targeting the old CS_proj, maybe rather than doing an asynchronous main, we generate an old main method like you normally would. The problem is everything all the way down, starting from this execute assembly async. So let's just jump to that real quick. Why is my resharper's disabled? 1 second. Let's refire this up. Resharper should not be disabled. I was mucking around with a bunch of my settings earlier, and I suspect I had too many Visual Studios open, and I just need to close everything down and relaunch. Because unfortunately, when you modify registry settings and other weird things to try to get your profile stuff working, occasionally you break stuff. And I think it just needs a good solid kick. But working through this, so it calls into an asynchronous method, and the problem with, or I shouldn't say problem, what ends up happening when you're working with async methods inside of C# is that it really ends up being async all the way down. So if you've got an async task method, everything that calls that really should be awaiting on that, and so you get an async task method who's invoking it, and it works its way up. There is technically async void. However, async void should be avoided in almost all circumstances. The one exception is top-level event handlers. So for people who have seen me do WPF, if you say you have a click handler on a button that needs to invoke an async method, that's an acceptable case where it's okay to use async void. I also personally extend that to mean async void is acceptable for command execute methods as well, because those are effectively top-level event handlers. But there is some, I won't say that's a universally held opinion. Let's just put it that way. Okay, there we go. Resharper caused Visual Studio to hang on launch. That sounds more right. Okay, so let's go find this method here real quick, and we will, come on. Come on, what's going on, Resharper? You've lost your mind? You still think you're disabled? Nope, you figured yourself out. Why do I not have my navigate methods? What is going on? This might be a quick detour while we reset environments. Though it seems like it's still figuring itself out. So Resharper might just need to be, it might just be trying to process the whole file. Come on, little buddy. You can do this. You can do it. It is important to make sure that you always talk to your Visual Studio. Hey, Mr. Demon Wolf. Unfortunately, this does tend to happen to me from time to time, especially I have an odd habit of getting my Visual Studio profiles in all sorts of bad states, and so I tend to just occasionally reset, pull the plug, and wipe and redo everything. So the fact that this little circle is sitting here is sort of what I'm waiting on for it to catch up. Yeah, I understand. Okay, there we go. That took way too long. Execute assembly, async. Go, 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 go. Yeah, I do tend to jump into VS Code quite a bit myself. There's a, if you go and find the previous stream that I did on System.CommandLine with John, I think it's like about an hour and a half, hour 42 in. He shows a pretty slick setup that he has for toggling out of Visual Studio into VS Code, keeping the cursor at the same position so that he can take advantage of the multiple cursor support in VS Code, which is always a clever trick. I need to go through, I had it set up on mine and then once again reset my profile, and yeah, need to set it back up again. Okay, so back to the problem. So if we were to go through and generate a synchronous main method, we now have the problem of we have this execute assembly async, and now we have async all the way down, and basically async throughout the rest of this library. So this is still technically up in System.CommandLine Dragonfruit land, but ultimately if we follow these methods all the way down, we'll end up down in the regular System.CommandLine core library with all of its extra stuff. So ultimately what we need to do is, let's jump back over here. There was a second request that came in about the parser Invoke Async forces everyone into the asynchronous pattern, which is normally fine, except for there are plenty of use cases where maybe you aren't in an async method or you're not in a system that allows for easy async. So then what do? And so the plan at some point was to go through and add a synchronous overload. Well, that plan now gets to be realized tonight. The problem is that there's only so many ways to go through and actually do sync over async. And so I'm going to share a couple links in chat. These are two articles from Stephen Taub. I hope I'm not butchering that too badly. And no, these are two separate links. So asynchronous wrappers over synchronous, and then the inverse of synchronous wrappers over asynchronous methods. So this one here is actually the case that we find ourselves in. However, these are very complementary articles and very worthwhile reading if you find yourself needing to do, or I should say, combining async and synchronous methods. So this is the case that we find ourselves in, and the too long didn't read version of this is there's not a great way of going back and forth. Effectively, there's a couple cheater options, which we're going to end up needing one of them a little later. Down in this, what if I really do need sync over async, which is effectively what we're going to run into. But in most cases, the correct solution is async all the way down, which means effectively having two versions of your method. Now, in C#, this ends up looking really weird because you end up with two methods that are almost identical with a few minor exceptions where you drop like the words await and async out of the method, but other than that, the code is effectively the same, which is really kind of frustrating. And from a lot of us programmers, we get this whole dry mentality stuck in our head of do not repeat yourself, do not repeat yourself. And it looks a whole lot like we're repeating ourselves. So we'll do our best to not, I should say, not necessarily repeat ourselves too much. But there is going to be a little bit of copy and paste code, or as I'll call it, editor inheritance. So, so going down that, just as a little bit more of an explanation. So there's a fundamental change that happens when you make an async method. Even though the C# looks the same, the actual compiled IL is very, very different. And that's fundamentally why you end up needing to create two versions of your API. So we are going to effectively start as though we were going to write this, and we're just going to follow this all the way down. And I think for now, in the interest of speed, we're just going to start from here, create a synchronous version, and then just chase the rabbit all the way down the hole, as it were, so that there are effectively two versions of this. So we are going to drop async from the name, change the return type to int, drop the async keyword, which means we can no longer await this method, which means we need invoke method, not async. So, and we are going to just follow this all the way down. So jump to here, and yeah, resharper is thinking. I'm very familiar with that concept. Oh, and it's literally right below me. So we are going to copy this guy, and just keep going. My plan is to come back through these methods and figure out how much of this code can be broken out and shared. But at least for the purpose of figuring out what the scope of this is and sort of how much we're going to end up falling through and needing to change, we're just going to start with the straight up copy and paste and work from there. So this gets us down into the parser invoke async, which is what that second issue was commenting on. This is effectively the point where we're switching from System.CommandLine Dragonfruit into System.CommandLine core or proper or whatever we want to call it. So this is effectively where we need to go. So we are going to go in here, and we probably actually are going to want to overload all of these. Let's do them all. I was thinking we might just pick on the one, but it looks like a bunch of these overloads invoke other versions of the overloads. So rather than selectively just picking a couple, we're just going to do them all. So invoke, this becomes task, this becomes invocation pipeline, invoke, and let's just keep going. So this becomes invoke async, and this might be a bug here. Come back to this. So there's a general idea with stack traces that in general you don't necessarily always want to just straight up return the task. You always want to await it, even if it ends up being a one-liner. And I might have to look at that one more closely. But in general, you typically always want to await your tasks. So that goes to there, that goes there. Let's see here. And invoke there, this becomes invoke. And I'm hoping when we get to this last overload, it all just kind of falls out. Yeah, see, here's another situation where it wasn't awaiting the task. It probably should be. And it looks like both of these overloads are going to end up falling into Invocation Pipeline Invoke Async, which is fine. That's kind of where we should be ending up anyway. Okay, you need to go not invoke async. You need to be invoke. You need to not be in await. And let's see, that leaves us just down to invocation pipeline. Invoke async needs to become straight up invoke. And this is where we're going to start to run into problems. So in System.CommandLine, there's an idea about commands, options, and arguments, and there's a whole bunch of kind of terminology that goes along with it. So over here, let's just jump back. I believe there was something about this in the wiki, if I'm not mistaken. And it could just be on the root level page. Try it out, contribute, syntax, concepts, and parser. So there's kind of a lot of stuff in here about what all of the terminology means and how this all breaks out. But the key part that we're going to be interested in is commands and subcommands. So for example, on something like when you execute .NET build, for the purposes of how System.CommandLine ends up parsing this, .NET is your root command, build is your subcommand. And ultimately, when you're doing a command line invocation, you only invoke a single command at a time. So in this case, the innermost subcommand is the command that's going to get executed. So in this case, build would get executed, or .NET add package. Package is the innermost subcommand, so it's going to be the command that gets executed. So for System.CommandLine, there's this idea of being able to attach handler methods to each of those commands. So when the command is invoked, it goes through and will invoke your method for you and pass the appropriate options or various other things that you might want. And you can attach both synchronous and asynchronous methods as command handlers, and it's perfectly happy to deal with that. The problem is now we've run into this state where we've got an invoke method that's being called, and if your command handler is async, we're going to have to deal with that here. So you'll note right here, it goes through on the command result, finds the command, and grabs the handler off of it, which is an I command handler, and then calls Invoke Async on it. And I think this is where we're effectively going to, I think this is where we have to call in the cheater methods. So we want synchronous all the way down as far as it's possible. However, at a certain point, it's no longer possible because this command handler is no longer going to be in our code. It's going to be in the user's code of System.CommandLine. And let's jump back over here. So on this article from Steven, let's see, offload to another thread. This is the key line right here of what we're looking for. So in general, you want to avoid .result calls. And I will leave it as an exercise to the reader. But if you go through his article above, he outlines why .result is bad and how it can result in deadlock and performance problems. So be aware, if you're using .result anywhere, go back and double check your code. You almost never want it. The key trick here is the deadlock situation occurs because you don't necessarily know the execution context in which your method is being invoked. So what does that mean? Some people may be familiar with the concept of thread local variables. The idea that you can declare a variable and decorate it with the thread local attribute, and for each thread that accesses that variable, they effectively get their own instance or backing field, as it were, for that variable. When the TPL was introduced with the task parallel library, there's an equivalent concept of async local, where when you're looking at code, so for example, above and below this await could very easily be different threads that execute on it. So thread local is less than ideal. However, there is a concept of async local where the asynchronous context flows through from before and after the await so that there's some means of preserving variables. And by doing this task run, what this effectively does is forces this asynchronous method off onto a thread pool thread where we know we won't necessarily have an execution context to cause a deadlock, and then call .result on it. Now, this is far from ideal, but it gets us out of the scary deadlock situation because there won't be a synchronization context for it to sync back on. And we should be able to run fine. Because System.CommandLine being a generic command line processor, it could be used in a WPF application. It could be used in an ASP.NET Core application if somebody wanted to process those, or just a straight up CLI app. So because we're acting kind of both as a library and a framework, we have to try and be diligent to block or to prevent problems from occurring. So I believe this is the trick that we want to deal with right about in here, because we've got two places where we've got invocations happening. So invocation chain, and I'm just going to have to dig through this for a minute since it's been a little while since I looked at this. One of these, I believe, is an asynchronous method. And let me turn off my notifications so those stop pestering. Because I believe this method right here is where we want to do the task run cheater mode. Because again, we want to avoid doing that cheater approach as long as possible. And one of these, so this adds in the invocation. This one aggregates. So first, second, context, next. So each one calls the next one. And then this passes it in. Invocation chain, context, task completed source. So this guy was the one that was previously, I think the problem is this var here is making it really hard to see what's happening. There it is. So this guy is a task returning effectively an asynchronous method. And that right there is the crux of our problem. So I think this is where we actually want to do it. task run, and I believe we just want to do this here, here. I think we just want wait, because I don't believe we care about the return. This is effectively a void returning asynchronous method. We'll wait for it here. We'll let this guy flow all the way through. And I think that gets us pretty close. So now we've modified a bunch of stuff. Let's go through, and I think what we're going to try next is to fix up all of the corresponding unit tests, because I want to make sure I haven't broken anything in the process, because we only modified a few files all the way down. Just take a look at exactly what it is. So one in Dragonfruit, invocation extensions, and invocation pipeline, and I suspect those might be unit tested in the same place. Let's take a look. Invocation pipeline tests and extensions tests. This is almost assuredly where we want to go. So I think, let's see here. So we have a command. We have a description set on the command with some help text. And when the command is invoked with -h, we expect the help output to be generated, or to be included in the output, which is fine. So I think we just start here and start cleaning some of this up. So rather than invoke async, we start with the name and work our way down. And we don't do invoke async, we do invoke. We no longer await it. We just do that. This is now a void returning method because it's no longer asynchronous, and away we go. Okay. I think we can probably do that most of the way down. It would be nice to share some of this code between these, but I don't think there's an effective way to do that. So this, and I'm going to switch this off of var because I don't think that's very intuitive that that's an int return. Root command invoke returning 0 when command is invoked. So we've got a root command. We attach a handler to it. This guy creates up an action delegate. It is worth noting, to create these handlers on the commands, this command handler class is the easiest way to go about doing it. There are tons of overloads for various generic sets. Currently the create is capped at 7 generic parameters, but it's worth knowing that if you end up needing more than this, an alternative option is to just declare a POCO and use that as the parameter and have it bind up there. That's probably simpler. So equivalent func return ones, etc., etc., etc. And get result code. I'm wondering if this is actually where we should change this. Because this guy here, you know, I'm thinking we may want to change up this code just a little bit. So rather than going through and doing this guy here, I'm wondering if we should push this down a little bit further. I'm thinking so. I am thinking that is what we want to do. So let's take this out, because again we want to push this down as far as we can go, which means this guy here, invocation chain, this, well, let's come back to that in just a second. So invoke async. I think what we want is invoke like that. So that gets that much going. Handler invoke. What are you squawking at me for? And add not-copass. Return a value. Well, what are you expecting? Invocation middleware. Oh boy. Oh boy, oh boy, oh boy, oh boy, oh boy. Because this guy wants a task. I think it's probably okay to just default that. Is that a change in behavior? The problem is that means this guy is effectively returning a task. So how to handle this? I do not know. I do not know. Let's come back to that in a minute. So because this is effectively our one spot where we do the invoke, copy paste again, implement the sync version, and then get result code. Async is going to become get result code. So we'll come in here, and I think because here we can avoid having to do that extra task allocation. So in the event that somebody has no asynchronous methods, we don't necessarily need to do task allocations unless the return type was a task. I think this is where we want to go through and do it. Let's see, same method's already declared. It's because we didn't rename it properly. Let's go back here. Because that's effectively what we want here. Is we want to return, let's see, this is awaiting the task. That's a problem though, isn't it? Because we actually want to invoke that. This invoke is what we want inside of that method. But I believe we can cheat this a little bit. Is that the same? So let's think this guy all the way through. In here we have, I'll just comment you out for the moment so you stop complaining. So we call dynamic invoke, which will run through and return the task already started. We call get result code on it. The problem being that that is not quite the same. foo async will now be invoked on the thread pool. Which is the whole point of doing this. So we need to do something slightly different up here. So where does result come from? One of these two places. So I think what we do is we're going to change this up a little bit. Boy, I'd really hate to do this. But I think what we do is something like this. Task is sealed, right? I think it's sealed. Because I'd really hate to go through and do this task run, which is fairly expensive, unless I have to. No, and so we could check. Oh, that might be a better option. Because what I'd really love to do is change this up so that rather than wrong spot. Okay, model binding handler. So that rather than doing this invoke here, this gets invoked as potentially part of a callback. Because at this point here, we effectively know our return type, right? Because handler delegate will have a method info that we can get the return type off of. Or handler method info will have a return type that we can also get the return value off of, or the return type off of. So in either of those cases, that would be acceptable. I'm just trying to decide how this get result code needs to work. So because we don't necessarily need to handle all return types, just task event and task. I'm wondering if something like, so just playing with this for the moment. So I think we do something like if is async method, and this is the more interesting case. Task run, get value. Just put you down in here. The question is what to actually do here, because this effectively needs to do this sort of thing with the context result code. If there's an integer return from the handler method, we want that. Otherwise, we want the integer off of the context result code. So, well, this is effectively where the switch statement would come into play here, but it's going to be more like this. And then we can actually go back to more akin to these, because this is effectively exactly what we have. And then this can become async. And that works a little nicer, and then this else case becomes the rest of the switch, where we do something like that. So this is taking advantage of the C#7 pattern matching, except for neither of these cases need to be handled. And it's more like this. Oh, thank you, ReSharper, telling me that I can throw that away. Wonderful. Does this work for me? It technically works. Not overly happy with it, but it works. So let's go with works first and then clean up second. So this is going to become lambda there, and this is going to become bool is async method gets. Let's see, this is a little simpler because this just becomes a straight up return. This goes away, and this becomes a straight up return. And this is so let's do the same check. If handler delegate equals null, then we will do, well, let's start with this. Type, return type. So the return type is either going to be handler delegate or handler method info return type. So return type equals type of task, or return type equals task of int. And that variable isn't needed anymore, and that goes away, and so then we pass is async method. I'm not sure I like the name of this. Let's rename this. I think it's more clear. How about returns task? Still not happy with it, but we'll come back to it again. Okay, so command handler is up here, and let's go. We'd started writing unit tests, and then I got distracted and decided to move some stuff. So let's start once again with these guys, and specific invocation handler. So command handler create. So aside from all of these calling invoke, all of these are ultimately going through Invoke Async, which is the same spot our other one went through. because ultimately a lot of these are trying to handle testing this model binding command handler, because right now this is the only implementation of command handler that's built into the library. Obviously that's an implementation detail and subject to change at any point, but currently that is true. So I'm trying to decide if any of these, let's just flatten these. So all of these are only async because they're doing command invoke async. This is the same entry method as before. I'm inclined to ignore those tests, at least for now, and focus on these ones. So this guy here, let's root command, okay. Always like even white space. Root command invoke async, root command invoke async. So let's once again change this up and make this a void return method, and then we'll actually run this and verify that things actually work the way we expect. Let's see, so this creates it up. This is no longer an async method, so we remove that. That becomes a straight up invoke. And then let's do this. Let's see here. Void return. Replace invoke async with invoke. Drop the await. I'm going to change this. Nope. I'm going to rename this, and then I'll auto code the var. Okay, so let's start with that, and let's make sure we haven't broken anything. And then we'll see about refactoring some of these methods for reuse. Because there's probably a decent amount of code, I hope, that could be shared between both the synchronous and asynchronous versions. Because you have to declare effectively two versions of the API doesn't mean that there can't be code sharing between them. Obviously, I started with the editor inheritance copy and paste approach, but that is just as a starting point. Okay. We'll let this guy go through and compile it up. I'm guessing there's a few more than 8 tests once this thing actually runs. I suspect this was possibly the live unit testing, discovering the tests as I added them, which is great. There's probably a few more, yeah, just a few things to compile and run. And as always, I need my caffeine to keep going. For those who are a little unfamiliar with it, I have a small caffeine addiction. There, that looks more like the unit test I was expecting. Like all the things. I suppose we technically don't need to be running all of these. I'm really mostly concerned just with these 39 for the moment. It's really all I care about. But we'll let the whole suite run for the moment, and then we'll go see about fixing up some more of them. I do think that we probably need some of the command handler tests to get changed, or at least more to be added. We'll see how this plays out. And most of these tests are fairly fast, but again, this was a clean clone-ish for me, so this hasn't been run in a little while. As you can see, most of these tests are pretty fast. The slow part is usually just getting the runner spun up and running. Huzzah! Those ones worked. Great. We are making progress. Let's see, model binding. So we only handled the invocation extensions. Let's handle the invocation pipeline as well. Let's go take a look at these. I'm going to clean out, declare tab bankruptcy, and start over. Okay, so let's see. Use middleware. And this is where it gets weird, because just because this is using Invoke Async, I do want to validate that Invoke behaves the same as Invoke Async. But most of these are just simply shelling out. Let's do this for the moment. Let's see, test, live unit testing, go. Let's get this going, and I'm curious to see this, because all of these do call Invoke Async. Parse result can be replaced by middleware. See, this is more testing the use middleware and less about the Invoke Async. So I think some of these tests are worth adding, but I don't necessarily think all of them are. So, for example, Invoke Async chooses the appropriate command. This is absolutely, because Invoke Async is the method under test, this absolutely should be added. But the ones that are testing the use middleware, I don't think it's worth having a second test to call invoke for something that's not actually being tested. So this guy here, I'm curious why I'm not seeing my let's see, output. Live unit testing has started. That's great. Why do I not see output results from it? Let's just continue through here. When middleware throws, Invoke Async does not handle the exception. Perfect. This is another great one. When middleware throws, Invoke does not handle the exception. So we should drop this. Invoke, which means no longer await, which means no longer async, which means func of int. Perfect. That should work too. When command handler throws. Oh, this is when middleware throws, when command handler throws. Okay, so that's fine. We should add this one as well. When command handler throws, invoke does not handle the exception. Great. So let's make sure we actually invoke the appropriate method. There's my live unit testing. Nice of you to catch up to me. My poor little machine trying to keep up with all of this stuff that I'm asking it to do. Okay, parser invoke. Great. Let's see, parser invocation be short circuit by middleware not calling next. I think this one I want to do because even though this isn't directly there, this ties into the command handler work that we just did. And I would like to make sure that those actually Don't do this for your method names. There's no way that will get past code review. But deal with that in a minute. I just want to get this rewritten first, and then we'll look at a better name. Because this is effectively that interesting case where we have a synchronous invoke and an asynchronous middleware handler. Synchronous. Oh, hey, that was not the order I pressed those keys in. Synchronous invocation can be short-circuited by async middleware not calling next. There. That's a better name. That actually reflects what it does. When no help builders are specified, uses default implementation. Great. When help builder facts, great. Those are all around the use help. And I can't spell. What the heck did we do here? Thank you. It is worth noting some of these unit tests do not play nice with live unit testing. So for now, I'm really only concerned with these ones. More importantly, whichever one just failed in here. So let's see. When middleware throws, this test didn't pass. This is a problem. So when middleware throws an exception, okay. Okay, live unit testing. I feel like you're causing me more problems than you're solving right now. So go away and turn off. Let's run the invocation pipeline tests. I'm sort of wondering if that was just out of date and didn't catch up with me in time, which is a very distinct possibility. You think about that, and let's continue on our way down. So that thinks about running these command handler tests are the next ones I'm interested in looking at to see. Okay, so that is legitimately failing. So what is the problem then? Expected system exception, but no exception was thrown. Very likely because we wrap it in a task.run and it's being swallowed. I would suspect that is the problem. So parser.invoke, invoke, invoke, invoke. Go to implementation. I do wonder real quick, something in the back of my mind is telling me that there was a comment about that swallowing, but I'm also realizing that my async handler is slightly different, because this is labeled as async. So I think what we want is that. I think what we want is that. I think I do that. That's not quite right now, is it, though? Okay, I think I was trying to be clever and not do this task run multiple times, but I think I just need to stop, get over myself, and just do it up here. Return task run. And results. Let's see here. So I'm going to need that, and then I'm going to need to return, let's see, cases task int. So I think we are just going to straight up cast this, because that should work. You're no longer value, you're now going to be task, return task, like that. Okay, get that out of my way. Let's see here. This is going to be task.run, get value, .wait. Oh, sure, we can go to a method group. That sounds great, thanks. And then that goes there. So the problem now is this switch. Let's see, int result code. I think rather than this, returns task. I think we're just going to do that. Whack all of that for now. Because this doesn't need to be get value. Let's see. Get value, we can cast to an int. So I think this one, the case and default need to be combined. If return context result code, otherwise we'll just throw. So that brings that out of here. I think the last bit is we're not going to be able to get away with this. So if and convert this all the way down. Okay, so this is quickly turning ugly, but I think this will come out okay. Else if return type is, I am wondering if this should be handling, there's a subtle change in behavior by doing this. And I should probably change this to not just be a straight type of comparison, because this will not handle derived classes of task. But in the interest of getting this working, we're going to start here. And the perks of this being a stream is I can go back and watch my video later and see all the things I forgot to do. So this will be a type of int, and return this guy all the way out. And then the default case just becomes what's left over. And that works a little bit nicer. Okay, so jump back to our caller, just right here, and we whack our Boolean, and instead just give it return type. Okay, as a general rule, I find that if I'm writing less code, I'm probably writing better code. Fewer spots for me to have bugs. Okay, and I think that makes the exception propagate through. I think. The key change is we no longer have an asynchronous delegate being passed into task.run. And now is just a straight up one. And I apparently got way too many closing braces and broke something. Okay. Try again. Because I think going to a synchronous delegate fixes the exception propagation. I think. Just note, this doesn't have async in front of it. Come on, throw the exception. Make me happy. So jumping back, just for those who are interested in noting, so we have a command and some middleware that's job is just straight throw an exception. Oh wait, this is middleware, not a command handler. Ah, and our command handler worked just fine. I still like the refactor, but middleware is losing. Oh, interesting. Oh, interesting. Oh, interesting. So let's look at that. So this is straight up middleware that is, oh. This thing down here that we so cleverly put in place. Again, don't do this, but in the interest of proving that this is the right change, let's just create a new delegate real quick. Call it 2. Rather than task, it's just going to be action. And this will be void returning. Okay. So hopefully this gets us one step closer to having a synchronous API where we only had an asynchronous one. Okay, so in the interest of testing, that becomes a 2, that becomes a 2, this return goes away. This becomes an empty action delegate. Boom. And this goes away because you now are void returning. Huzzah. Okay, so what is your problem with, okay, let's collapse this, you're just in the way. Let's see, list configuration middleware. Right, and this is assuredly where our problem lies, because this is the collection that's being added into. Oh sure, we'll update. We'll update to the fancy new pretty operator. So For those people who didn't catch that, there is a new operator. So when you previously had to do the null coalescing and then effectively do a setter on something, you can now do that in a single line. Because C# is awesome, and the creators like to make it so that anything that we have to type repeatedly, we don't have to anymore, which is awesome. Okay, so in our unit tests, we're adding a piece of middleware to our configuration list, which is what this use middleware ultimately ends up doing. So this extension method here calls builder add middleware, which registers up and adds something to the list. That may change my mind on where this needs to go, because we no longer have the problem of a synchronous main method needing to call an asynchronous command handler, but we also have a synchronous main needing to call asynchronous middleware, which is effectively one of the cases that's being tested here. In that we expect that if this middleware goes to throw an exception, that that exception properly propagates all the way out, which it's not. It's being swallowed right now, which is all coming about because of the obnoxious way that I implemented this. Because if we go back to this delegate, that guy is now happy. This guy is now happy. Because the command handler stuff is effectively being implemented as a middleware. I'm going back to where we had it before. I think that is the better approach. Because we don't really have synchronous middleware. What was that? An async delegate? Yep. So asynchronous delegate passes all the way through. That works, that works, that works. This becomes task completed. And then where we previously had to await it here, we will do a task.run. Actually, we can just do wait. I guess we end up with this, right? And that, let's verify that this works. Because the fact that this is swallowing the exceptions is being somewhat problematic. Because I would like this to bubble all the way through. Something in the back of my mind is telling me that that's expected. There we go. There we go. Okay. I'm thinking this is the appropriate place to implement the cheater approach. Because if we try to do it further down, we run into this problem of users can effectively not necessarily have their own callbacks at the command handler, but they can have arbitrary callbacks at the middleware. Yep, so let's go Team Explorer real quick. Let's see, command handler. Let's move you over here, unit tests out of the way. So throw away that change because we don't need it anymore. We are only going to invoke directly, compare with unmodified. I think this guy here, command handler, goes away as well. Don't need it. Let's see here. Oh, let's just continue down the list. Let's make sure this works. So there's all the invoke overloads. This one we want to throw away because that's a horrible name for a delegate. Okay, and this is effectively our cheater approach here, where it builds it up. And model binding command handler, I think this is where, yeah, we no longer need that anymore. So we keep it simple. We hijack it at the invocation pipeline. And everything works. And I think this is just the operator update. Yeah, so we'll flatten that in. Okay, so close all documents. And let's just real quick make sure I'm not crazy and that all our tests still run. I think we're probably pretty close with each of these. Because the next thing that I would like to do before we jump all the way up into Dragonfruit is go back and look at these methods once we verify that all our tests are passing and do a little refactoring. Because we have a lot of duplicated code that I think can be reduced into into some shared methods. Like even these where there's just invoke methods, this bit is duplicated across, or at least this much is, and there is no reason that it needs to be. So I think we could, well, yeah, we'll see. I think there's room for improvement. I think we'll start with Invocation Pipeline, though. This is probably the biggest hurdle, is this guy right here. But again, I want to make sure that all my tests pass before I get too carried away and just start hacking at code and replacing stuff. Okay, I'll quit playing around. I'll wait for the unit test run to finish. Come on. Come on. You can do it. You can do it. Whew. Man, the streaming really does slow down the running of Visual Studio. I think there's a competition to see who can chew up the most memory and CPU. Okay, well that's thinking. I'm going to go start looking at this. Invocation Pipeline. Okay, so we've got collapse you, collapse you. Okay, so we've got these two methods, Invoke Async and Invoke. And effectively, this much is all the same. In fact, everything is the same except for this one line right here. So I'm thinking we can combine some code because that's a lot of duplication. So I think the first thing we do is probably start whacking some of these vars. Yeah, so all the tests pass. Great. So private void foo for the moment until we figure out what we're doing here. And I think I'm going to bring this guy down. Let's get rid of this var real quick because I think this invocation middleware, I think this much we just want to take wholesale, right? So let's go with console, bring that in. Let's see. How about build invocation chain? And we'll return the middleware back. Nope. Try that again. That and return. So this becomes build invocation chain, pass in our console, and all of this goes away. Right? Oh, so this guy is still going to want the context and context. Okay, so we changed this guy up. So rather than taking in an iConsole, he'll take in the context. And we'll bring this guy back outside. And this becomes context. Simple enough. So this gets a little better. We take everything up from here. And, well, let's just change this to be build invocation chain, context. All of this goes away. That cleans all of that up. Okay, bring that up. Okay. And all of this is just to get the result code. Method can be made static. Excellent. So private static int process or apply result, apply invocation result. Seems wrong that, let's see, this guy really should just take the context. And we're going to bring u in and u in and return apply results. Not sure I like that method, but it'll do for now. And then this becomes return apply result context. Okay, so that cleans that up. I don't know if there's much more usefulness that can happen from this. Let's first make sure we haven't broken anything. And I'm trying to think of a better name for this apply result method. Because it checks the invocation result, applies it to the context, and then grabs the result code from the context. I'm wondering if get result code makes more sense. I'm thinking get result code might make more sense. I'm going to let this thing run first, and then we'll just do the rename. But I think get result code is going to be the winner. Good. Result code. And I lied about waiting. I'm impatient. So let's go back here and look at our other guy. Invocation extensions. This guy here has, let's see, use middleware, use debug directives. So we tried to not be too opinionated on the API for this because some people like fluent syntax, some people don't. But at least when it comes to building up this command line builder, the builder itself does follow a fluent syntax. The builder pattern really lends itself well to that. So that one does exist. Okay, so we've got all of these invoke asyncs. And I think this parser, this builder here might be the only bit that I could reuse. Because effectively the difference is this invoke async. I guess building out the parse result could be shared. Yeah, let's share that. So private static. This isn't clear what this is. Parse result. What do we call this? Parse for now. Let's just bring this stuff down. Let's see, because you're going to need a command. Let's see, command, and you're going to need some string args. Nope, one too many things. So that gets that much through. Let's see, just verifying. This does take a command all the way through, and this is effectively just straight return, parse with defaults. So this becomes parse with defaults. Too many parses, too many parses. Cool it down, cool it down. There we go. So something more like that. I'm wondering if we should go one step further and return the invocation pipeline. Too much? I don't know. I always have mixed feelings about sometimes trying to do these types of refactors. It's easy to get into the habit of two things look alike, therefore they should do the same thing. And I'm not. Just trying to decide if this is, come on. Get invocation pipeline, command args. Is that a better looking API? I mean, it certainly reduces this down to a one-liner. Is that good? There's an argument to be made that these things should be separated, but for now, we're going with it. Because that will at least save us a teeny bit of code. And in a lot of cases, those one-liner type methods, the compiler will inline, which might very well help. So let's go ahead, just make sure. I don't think we've broken anything here. Rerun those, and then let's go and work our way back up because we made some changes to Dragon Fruit. And I believe we have some reasonable unit tests on this. So execute assembly. So let's go look at the unit tests on that and see what needs to be done, and then after those are passing, we will go through and see about actually running it. The hard part for this is part of what System.CommandLine System.CommandLine Dragon Fruit does is this entry point discover and execution on that. So there might not be that many unit tests directly on that method. So let's just pin you for the moment. You go ahead and sit on the side. Because it wants to act on an assembly, which means it would have to have a compiled assembly to act on. Let's take a quick peek. Expand out Dragon Fruit, command line, because there's those command line tests. Execute assembly async. That's the unfortunate part. No reference. Oh, 6 references. Where are they all? Let's see. Perf. And Dragon Fruit. And then the rendering playground. Not helpful. Artifacts, OBJ. So the short version is there are no direct tests on this guy. And the hard part being that this would require an entry assembly, entry point full type name, XML docs. Oh boy. Oh boy, oh boy, oh boy. So let's see, entry point. There's not a lot of code sharing to be had here. Though there's definitely a need for unit testing over these methods. The problem being to test something that takes in an assembly probably means reflection emit to generate the assembly on the fly. I'm trying to think if there's a better option because that is ugly. Ugly, ugly, ugly. But certainly doable. Thinking for now, given that this one wasn't unit tested, I might just not bother with this one at the moment. And let this guy go. I think that makes it simplest. Okay, so with that said, let's go and see about submitting a pull request. I've already forgot my issue number, so let's back up. Let's see, not that one, this one, 412. Excellent. So branches, new local branch, fix 412, created off of master. Oh, what am I doing? I've got Kraken open. Let's go play on Kraken for the moment. So new branch, great. I think we want all of our changes, so let's stage them all and just quickly scan them again just to make sure. It is always a good idea to review your commit before pushing it. So execute. Oh, I forgot about invoke method. And this is what I'm glad we checked. Because this one, I believe, does have unit. I believe this one actually does have unit tests on it, because it's much easier to unit test a method info, command line tests. Yes, it does. Yes, it does. Okay, so we want to duplicate these. Okay, so we do want to do a little work here. Okay, so before we get carried away, let's get the unit test working. Okay, so this becomes a void. We need to have a better name. This becomes invoke method. This becomes await. Test program, test method info. This is a synchronous method. And it executes synchron. Also, if it wasn't clear, my spelling is, we'll say lacking. So, let's see. So, collapse. Let's see. It shows help based on XML docs. See, all of these are, I think, fair game, because ultimately what these are testing is the builder configuration. So this becomes not async, and this becomes a void, and thinking there's probably some code reuse that can be happening in here, because most of these tests are not the invocation, but the method here. Just grab this, because I think this is... I think that's ultimately what we're going to end up doing here, is making a lot of these things just straight up synchronous. Oh, nope. Clipboard pollution. That one. So that goes away. You become a void. You become a synchronous call. It does seem weird that these exit codes are testing for 0 despite these methods both being void returns. These unit tests are very much lacking. There's a lot of cases in here that are not being covered. This is passing a target of null. which is fine. So let's make that guy static. And this becomes a void. This lacks the async. We drop the await. And that all works. And last one. Let's see. So void here. And we go here and here. Make sure that all works. Okay. Rerun the dragon fruit tests. Let's make sure we didn't break anything. And then I think there is room for these two methods. We can certainly do something. Building up this parser is an easy win. Just make sure all these tests currently pass. And we should be good. Perfect. Okay. Private static parser build parser. And we are just going to grab all of this, bring all of you down, and let's see, return. And we need method. Let's see, XML docs and target. We need you three. We'll keep them in the same order. There is no point in these things being optional on a private helper method. So this then becomes build parser, method XML docs, and target. Wax this. And then this is common shared code. Okay. Unit test all the things. We'll go back and stage those additional changes. Okay. So let's just double check these. This does still bother me. I want to share some of this code in the test, and I'm not sure a great way to do it. I'm not sure there is a clean option. Yeah, I'm less concerned about those. Okay, let's check command line. So you're still running. Okay, so execute assembly. We said we weren't going to directly unit test. Instead, we'll unit test the invoke method calls. Great. Invoke extension tests. Same thing all the way down. Duplicate tests. Let's see, invoke chooses the appropriate command. All of these ones. Yeah, so that's fine. It looks like we covered all of those unit tests that matter. This is just the refactor for the new operator, which is great. Huzzah. Let's see here. So invoke async, invoke. We've got our shared method down here. This adds an Invoke Async, an Invoke, and a cheater method down here. Shared logic for building up the middleware, but we cheat there. Perfect. So fixes pound 412, and that is not a 4. This adds a synchronous overload for parser invoke. One of these days I'm going to learn how to spell synchronous. Let's see. Parser invoke. Also, let's see. That's effectively for Invocation Pipeline invoke. This change propagates up to parser.invoke. In System command line and up to, what was the command line? Execute assembly in System command line. Dragon fruit. Dragon fruit. Perfect. Commit change and great. Push. Let's see. We can't go to origin. Go to my fork because I do not have push permissions all the way up into the .NET System command line. We will pull request this guy in, and hopefully it gets reviewed and merged not too long. So let's jump over here to pull requests, and oh, does it not show up here? Maybe the helpful button is only on the root of the repo. There we go. Hey, give it back. There you go. I'm going to move this down, put it a little bit better. Added SPI overloads. Just kind of scan this real quick and make sure this still matches what we expect and that there's nothing new, nothing unexpected. Still just these same unit tests, operator change, invoke overloads, shared method, because this is effectively when somebody goes to review this, what they're going to be looking at. So going into master from my branch, great, create pull request. Perfect. And we will let that guy cook and roll, and hopefully that goes through. I'm going to hold on here for just a little bit just to make sure that the CI build passes. It can be a little bit problematic at times. The kind of backing CI pipeline is called Arcade, and as you can see, it compiles for everything because we want to make sure it's tested across various configurations and operating systems and that kind of thing. So just going to let that guy chug for a little bit, and then we will come back. So switching gears off of System command line, for people who are interested, I have been looking at an outline together for the material design and XAML stuff, specifically for things to go into the 3.0 release. I've been somewhat ignoring chat for a little bit, just trying to get all of the documentation and pipeline work done for the 2.6.0 release. So anyone who's looked at the history has probably seen a huge number of YAML changes from me, just trying to get stuff working. It's been a good learning experience, I'll say that. So hopefully that release is coming in the very near future, as soon as I can get my act together and get the rest of those tasks done. I've got a personal deadline of trying to have it done within this next week, but don't hold me to that. That is just a personal deadline of my own. The other thing for people who are interested, I did start working on what I think will be probably a quick series on using Snoop for WPF debugging. I find that the hardest skill to teach and explain to people is actually debugging type knowledge. And so I was figuring that a short video series on that would probably go over well. What I will probably do is just live stream it and send it through, but then the videos that actually go up to YouTube, I will probably spend the time and actually do some editing. Normally right now on all these videos, because my free time is very limited and I'd rather spend it being productive rather than editing videos, I've just been blind uploading all the videos straight. So hopefully I get to that sometime. I won't promise, but if people are interested in, please shoot me a message on Gitter, or you can get in contact with me. I think most people probably have found my Twitter and got here from there. If not, I don't actually have it here. One second, we can grab this. Let's see here. So let's grab, if I do this, and I can grab this item and copy, coding, and paste duplicate. That is not what we were going for. Remove. I might have to play around with this. But for those people who are looking for me, you can find me on Twitter at KITOKEBOO. Sweet. It looks like most of these are passing. OS X and Ubuntu are done, and it's just the Windows builds that we're waiting on, which is awesome. Hopefully this guy all goes through nicely. I think with that, I am probably going to be signing off for the night. It is getting close to my 2-hour mark where I usually try to call it quits. But I will get this guy merged in. I don't know if it's going to necessarily make a live stream or not, unless people tell me that they're interested in doing it. But the actual fix for this issue should now be possible now that the async main is no longer going to be a requirement. It should be possible to go through and generate up that targets file correctly. Because the comment here, could the targets use a conditional that would output a synchronous main? And the answer is yes. That's effectively exactly what needs to happen. The problem before is generating a synchronous main wasn't actually possible because the API was async all the way down. And we didn't want to do the cheater mode for the sync over async at the root. We wanted to push it down as far as we could through the library. So for anybody who finds these interesting, once again, this is the article that I was relying very heavily on from Stephen. Again, it's an old one, but it's one of those concepts that I find that a lot of people don't necessarily spend the time to dive deep into the task parallel library for the async and await, and I think it is very much a worthwhile endeavor to understand it. Cool. All of the platform builds passed. So with that, all checks are done. Now we just have to wait for a review, which may take a while. I know that John mentioned that he was going to have to be on break for a little bit from this, so hopefully when he gets back, it doesn't take him too long to get it reviewed and call out all of the mistakes that I made. So with that, I will sign off, tell you all good night, and happy coding.